Hey, James, thanks for being here. I understand you've got some things you wanted to show us, some stuff that you've figured out recently about MCP servers.
Yeah, thanks for having me here, Jason.
Yeah.
So I've been playing around a little bit with remote MCP servers quite a bit recently. I feel local MCP servers are where things started with MCP, but I feel as more and more companies start to add like MCP support instead of the traditional API that you might integrate with, you might want to have a conversational chat with some kind of remote service, then I think remote MCP servers are going to become more and more powerful slash popular.
Yeah.
And obviously I've got a very serverless view of the world. And I actually think, maybe slightly biased, that serverless is one of the optimal places to run remote MCP servers. If you think about the typical use case that serverless is really good at, it's really unpredictable workloads that's going to scale almost infinitely to handle lots and lots of requests concurrently and kind of do that without you as a person owning that MCP server needing to think about, is my infrastructure going to scale or not? Like things like AWS Lambda just scale, and that's a whole category of things that you no longer need to worry about. So I've built a little sample app using Lambda and serverless, all the AWS serverless technologies really, and added some MCP support to it.
Okay. Awesome. Yeah, let's take a look at it.
So if we start with the end in mind and start from the actual example, I've got this whole GitHub repository that has got this big serverless sample app in it that does a whole bunch of other things that aren't MCP. It's a big sample app to demonstrate various different serverless services, how to build different serverless things in different runtimes with different infrastructure as code tools. But as of this morning, the main branch now has MCP server example. And if we start with the end in mind, this is the kind of front end that you get as part of this sample app. And if I just log into this sample, it's a dummy e-commerce slash coffee shop website where you've got a list of products. The products have stock. There's 6 or 7, maybe 8 now different microservices in the background that are all in charge of managing the product catalog, managing stock, managing orders, managing loyalty points and users and things like that. You can go in, you can create an order. I want to order an espresso and a cappuccino. I can say proceed to checkout, and that'll go off and create an order. Now, so one of the things I've added as far as MCP support goes is the ability to talk to this whole backend in Claude Desktop. So if you're not familiar, for anybody listening, that you can actually add remote MCP servers to Claude Desktop. And there's a couple of ways of doing that. One is if your app supports full OAuth 2.1 and dynamic client registration, there's this whole authentication spec inside the MCP spec for what it needs to support. You can go in here and you can click add integrations, and you can add a new integration, and you can just pass in the URL for your MCP server, and all of the auth is just handled for you. My sample app isn't quite that advanced yet. So if you don't have the kind of full OAuth 2 compatible authentication for your MCP server, if you open up Claude Desktop and you go to settings, go to the developer tab, and then you can open up this little config file that allows you to basically configure MCP servers that you want to connect to. So I believe if you were doing actually local MCP servers, this is where you would configure your local MCP server if you were running one locally. And what this is basically doing, so there's this NuGet package called MCP Remote. As I understand from reading the docs, all that does is set up a local endpoint, a local MCP endpoint to act as a proxy to the remote MCP endpoint, which is what we're doing here. So we're going to run the MCP Remote command, passing in the endpoint for our remote MCP server. And because obviously, if I'm going to go and place an order with Claude, I need to be able to authenticate to the backend. So I'm also going to manually pass in an authorization header, passing in a bearer token, and then I've got my auth token here. The current hacky implementation of this means that after you've actually logged in, you need to go into your browser and go to your local storage and actually pull the JWT from your browser. Security people, please don't shout at me for that. So there's a whole bunch of actually really cool, so you can do all sorts of stuff when you use this MCP remote package. You can pass in, like, if you are doing full like OAuth 2, you can pass in client IDs and client secrets. You can pass in scopes. Like, there's a whole bunch of additional arguments you can pass to this MCP command. But yeah, at the minute, we're just passing in an auth header. Once you've configured that, then inside Claude, you get, if I go back to here now and I start a new chat, I actually get my remote example here, and I can see the tools that remote MCP server has available. So I can say, hey, Claude, can you tell me products are available. I don't know if actually, Jason, like, how does it know which MCP tool to call? I guess it's based on what the description of the tool is compared to what you actually type.
Yeah, that's the way I imagine it in my head, is because you just asked it, you didn't even give it context of, I want to look at the espresso. You just asked what products are available, and it just went straight to that. So there must be some sort of logical thing where it goes straight to its tools to try to understand, is this what they're asking us?
Yeah.
Type of thing. But honestly, I don't know. It's a black box.
Yeah, I wonder if, I've probably been the actual tool on the MCP server is called available products. So I've probably been, I wonder if should we try and break it?
Hey, let's do it. Let's hack it.
Can I order an, that's going to be too easy because one of the tools is called create order. I'd like an espresso, please.
There we go.
Okay.
Okay.
So
it doesn't really know what you mean there.
Yeah. I wonder if we can have a look at this when we look at the actual code for it, but in the tools, you can configure like the description of the tool. So I wonder if there's going to be something eventually in the world of MCP where you need to get like really detailed in your description of what the tool is, what the tool can do, maybe eventually.
Yeah. In the config, you kind of have to do that now, but I don't know if maybe order is the trigger word just based off the names of the tools.
Yeah.
But
let's try that. I'd like to order an espresso, please. Interesting. So it knows to check the products first. I've never actually tried this. I've never tried this before. Let's see what happens. It's interesting that it's gone to check the products first. And I'm assuming it's going to look, because when it gets the products, it's going to return like the stock of each product. Assuming / hoping that it's going to.
Would it maybe filter out just the espresso?
Yeah.
We need some Jeopardy music here.
Yeah. Come on, Claude.
So I guess without jumping too far ahead, because I know you have some code and stuff you want to show off, but is the inventory that we're assuming checking right now, is that in a database somewhere?
Yeah, so that's in a DynamoDB table inside AWS, behind a Lambda function, behind an API gateway with authentication and stuff like that. Yes.
Okay. We might have broke Claude.
Yeah, I broke something, haven't I? Let's see.
Oh, there it goes.
So it did get it back. So why?
Okay. It was just a little hung up.
Okay. I'm going to start a new chat. Let's try this again. Can you tell me what products are? Let's go back to the kind of original with typo example. So it's going to check the products. Yeah, it doesn't seem to like this, does it? Let's leave that running. Let's have a look at the code and we can come back.
Yeah, I was going to say, maybe this also indicates, is there something wrong with the Lambda? Do we need to
potentially
troubleshooting?
Well, we could do some troubleshooting.
Yeah.
Let's just
don't let me derail you. I know you.
No, it's good.
Wanted to talk about.
We can do some trouble. I'm just going to open up, because the other thing I wanted to show is how you can observe MCP servers, remote MCP servers as well. So I'll open that up in another window. So let's look at the code briefly. So this, like I said, all this on GitHub, this is all just Lambda functions written in TypeScript. I do have to give some props to one of my old colleagues at AWS, Anton Alexandrov. And there's a bunch of others who contributed to this repo of sample MCP servers. This is AWS managed, how to run stateful MCP servers, how to run stateless MCP servers, like a whole bunch of different things. And it was Anton who kind of started this line of thinking. I'm probably going to do a webinar later this year, actually, with Anton in collaboration with AWS to talk about running serverless MCP service, probably a longer extension of what we're talking about today and a bit more into the weeds, if you will. So this is where the genesis for this came from. And there's a couple of features of both Node.js, which is why I've chosen TypeScript to run this, but also of Lambda itself to make this really easy. So if we have a look at the actual code, we've got this index.ts file. So this is all actually just using Express. So Express, the framework that lots and lots of other Node.js web frameworks have been built on top of, as far as I understand it. Like, we've just got a standard Express web server here. We could run this locally if we wanted to. The reason that's really helpful is because actually between Express itself and the actual MCP SDK for TypeScript, it actually makes it really easy to bootstrap a new MCP server, MCP compatible endpoints with Express, if you will. So there's a whole bunch of config here. You can ignore a lot of this auth stuff because it doesn't actually work, as you saw with my hacky little take the auth code from the browser. The key bit here is down at the bottom here, we've got this bootstrap endpoint. And this bootstrap is another code file inside this same code base. And this is where we're actually mapping up the MCP endpoints. So when I've got this kind of constant here, which is just /MCP, like this is the endpoint that we expect the MCP client to make a call to. So when this is hosted on AWS, you'll have an endpoint, an API endpoint. You make a call to that API endpoint /MCP, which means you're going to hit Express, and then you're going to hit one of these MCP paths. And then you've got these individual request handlers for each of post, get, and delete, the three things that the MCP needs to do to connect and to send messages and stuff. And then inside, if we just look at one of these handlers, we're going to create a new MCP server. This MCP server comes from the actual MCP server itself. So we have got this MCP server import that's coming from the gear. We can create a new MCP server and we can map up all of the tools. So you'll see, I'll come back to the actual internals of these tools in just a second, but you've got 4 tools. If you remember in Claude, we had the 4 tools available here. So in terms of a flow, the request comes into the app, it'll launch Express, it'll be on the /MCP endpoint, which means it's going to end up in this request handler here, which is going to create a new instance of that MCP server we just saw very quickly. And then it's going to actually set up the transports, parse the authentication header from the inbound request. If you remember in that MCP remote command, we passed in the -header bearer token. So we're parsing the bearer token from the inbound request. And then we're just setting that as part of the parameters that then get passed onto the actual MCP server. So this here is basically saying take any other parameters that come in. If you think if you were creating an order from inside Claude, you'd need to pass in the product that you wanted to order. So we're basically saying take in any existing parameters that are passed in to the request to the MCP server, and also add the authentication token on top of that as well. And then we're going to call this handle function, which then gets down into the actual MCP server itself. So this is all from the MCP SDK for TypeScript, JavaScript, if you will. And we've got our individual tools here. So we've got the get available products, we've got the create order, we've got the get order status, and we've got the get my orders, the 4 endpoints. And what these endpoints are doing is basically just proxying so this MCP server running on Lambda has the context to know where the downstream APIs are that it needs to talk to. Because obviously, like I said, there's 6, 7, maybe 8 microservices behind the scenes here for managing orders, for managing products, for managing various other things inside this app. So I suppose you can think of this MCP server as like an API gateway. So if the request comes in, if the MCP client wants to call the available products, we're going to create a new instance of our product service. And this is where we'll actually go off and set up the HTTP client to make them downstream API calls. The way all of this works when it gets deployed into AWS is all the services store their own API endpoints in a parameter inside AWS. So when you create a new instance of this product service, you're going to go and get that parameter. So the current environment, the product service, the API endpoint, and then use that to create a new instance of Axios, which is probably the most commonly used HTTP library in TypeScript, JavaScript.
So I got a question for you.
Go.
You mentioned that this implementation, this approach is similar to just having an API endpoint. That begs the question of performance differences or cost differences. Like, why would you choose this over the others? Is it just simplicity or ease because it's easily integrated into Claude this way? Or do we need to think about some other things? Security too, I guess.
There's definitely a security thing to talk about. as I said, the whole let's take the token from the browser local storage and paste that into a JSON config file inside Claude is absolutely not the right way to do things. Maybe we do another video, actually. I've got another example of another app that I built that actually has the full OAuth implementation that we can maybe look at in another video if we want to record another one.
Yeah, we can do another one of those for sure. But I'm curious, and I know you instrumented this with Datadog, but to me, I would be very curious to know like the call times and the latency differences approaches.
Yeah, I think your cost conversation is an interesting one, particularly because I don't know. I think if you imagine like an API in the traditional sense, if I wanted to expose this product, let's say I owned this coffee shop, this was a real coffee shop, and I wanted to allow people to place orders in my coffee shop with a traditional API, they need to be a developer, right? They need to understand software. They need to understand how to make API calls. They need to understand all this stuff. Whereas actually, if I can talk to Claude, I can talk to something in plain English and say, hey, I want to order an espresso from my favorite coffee shop. Then it's almost like maybe arguably opening this up to other. Yeah, it's a different way of calling it.
It's a new interface.
Yeah. One of the downsides to your point, like because all this MCP server is doing is acting as a proxy, whilst this MCP server is running, this is going to be, let's say the downstream system takes 3 seconds to respond. You're going to be paying for that downstream system. Imagining that's running on Lambda as well, which this is. That downstream system is going to be running for 3 seconds. So you pay for that, but you're also still paying for your compute in this function because this function is still running and waiting for that response. So you would in essence end up double paying. There's maybe an optimization here where you, rather than having an MCP gateway, each of the individual backend services would all expose its own individual MCP server. But then from a configuration perspective in Claude, you need to configure like 10 different remote integrations.
Yeah, but that sounds like some trade-offs.
Let's have a look to your question about observing how all this works.
Cool.
And again, going back to another video we could potentially record is, I know this is all running on Lambda, and I talked about serverless being a good place to run MCP servers. Cloudflare has a really interesting way of doing this because Cloudflare's serverless function product workers, you don't pay, whereas Lambda, you pay per millisecond when your code is running. Cloudflare, you pay per millisecond, but you don't, it's per millisecond of CPU time. So whilst your app is doing I/O, you don't pay. There's no charge, which is interesting for something like this. So let's have a look. So again, I'm in Datadog here. Let's just zoom this in a little bit. All these Lambda functions I've deployed have been integrated with Datadog's Lambda instrumentation. It's basically as simple as add a layer to your Lambda function and the rest works. Like you'll notice if I very quickly go back to the code JSON, like you've not seen any mention of a Datadog tracer anywhere in here. Yeah. No, if I look at my package.json, oh yeah, so DD trace is included as one of the dependencies. So the library is there, but if you look at the actual, even if we look at like the services that are making the downstream API calls, this is literally just saying fetch. So it's not even using access here. It's just using fetch. It's using the native fetch JavaScript calls. There's no instrumentation here whatsoever. Yeah. So if I go and have a look in Datadog now, so this has been tagged as the order MCP service. So if I have a look, let's have a look at the last hour, and I can see there's a whole bunch of stuff in here. And we can actually see let me just filter this actually. Resource name is post MCP. I think that's right. Yeah. So we can see in the last hour, there's been 5 calls to this MCP endpoint. I'm going to pick on this one here just because it's the longest and there's 51 spans, which seems interesting. And so what you can actually see here, if I just collapse this up and expand it bit by bit. So we've got the initial API request that came into that /MCP endpoint on our Express application. Yeah. That then made a call to SSM, which, if you remember, I said the parameters are held in, as in the downstream API endpoint, are held in parameters inside AWS. So that's going to be the call there to actually retrieve that parameter for the API endpoint. And then we can see here the post request was made, and that post request was made to this URL. But what's really interesting is, and again, I will repeat this, that there is 0 actual extra instrumentation in the MCP server code for this. I've now actually got the downstream system in here as well. So you asked before, like, where is this stock information held? The orders information happens to be in DynamoDB, and you can actually see the downstream call to DynamoDB that the actual orders service made. So this isn't the MCP server. This is like the downstream API call. You can follow this through to even say, hey, we can even see off the back of this initial MCP call, the inventory service actually had to go and do some work. And you can see this as part of the graph to say, hey, actually, all this other stuff has happened off the back of that simple conversational interface.
Yeah, that's great to see that visually broken out like that.
These always look fun.
Mm-hmm.
I don't think they're particularly useful for graphs, but they're nice and pretty to look at. I like this view's a better view. So yeah, so to your point about of the cost of this. So you've got this initial request here that ran for 1.24 seconds. So that's going to be that Lambda time. And then as part of that 1.24 seconds, you've got this 1.6 seconds here, which was like the downstream order service. This happens to be running on ECS in a container. So this probably isn't the best example. If this was running on Lambda, you'd be paying for 1.24 seconds of Lambda time here. And then you'd be paying for another 1 second of Lambda time here as well, because this function's waiting for this function to do some work. So there is that. And I think one of the things about that's really interesting when you think about building remote MCP service is actually, I'll give Anton credit for this phrase because Anton was the one who said it to me first, but MCP servers are just applications. They're just apps. And that means you still need to observe them. You still need to secure them. You still need to think about so me saying you still need to secure them after just demonstrating how to take a token from your browser local storage and paste it in your file. But anyway, you need to secure them in some way. All that stuff is still really needed.
For sure. But this definitely opens up a whole other realm of possibilities and conversations and very creative ways of providing solutions.
Yeah. And I think the one last thing I will just point out, actually, just because I heard there's two parts of Lambda that make this all hang together. And there's another really important one for people to know about, because for anyone who's familiar with Lambda historically, like you'll know that when you build a Lambda function, you define a function in your application code in whatever language you're using, and you say, hey, Lambda, when there's an invoke of this function, call this function in my application code. It's really confusing that they call it Lambda functions, because whenever I talk about it, you say function in like two different meanings.
Yeah.
But you'll notice actually in here, all we've got is this like index.ts file. This is just an Express application. There's no Lambda handler in here as such. And the thing that makes all of this hang together is this thing called the Lambda web adapter, which I think is probably 2,400 stars on GitHub. So maybe it is starting to get a bit more popular. But at least when I worked at AWS, it was maybe not quite as well known as it should have been, really. Because what Lambda web adapter allows you to do is basically run any web application on Lambda. If your application can run and expose a HTTP endpoint, Lambda web adapter allows you to run that on Lambda.
Really?
It kind of works as like a proxy. So the way Lambda works internally is a bit of a sidestep away from AI stuff very quickly, but Lambda's just got an internal API endpoint, and all the Lambda runtimes are doing, so like the Node.js runtime for Lambda is literally just sat on a while loop, calling this internal API endpoint to say, hey, is there a new invoke? Yes, there is. Pass that to the function. So what this Lambda web adapter does is it's this Lambda web adapter that is talking to the Lambda internal runtime API. The Lambda web adapter is going to take that inbound payload from from the internal API and then make the HTTP request to your actual web app that's running in the same environment as the web adapter.
Wow.
So this is probably the key thing that kind of makes this easier to build, in that you can just define an Express.js application. If you were doing this in .NET, .NET allows, I think there's an MCP SDK for .NET. So if you're a .NET developer, you could build an MCP server in .NET and then host it on Lambda using the Lambda web adapter. It's just running whatever web framework you want to run inside Lambda. Now, historically, that has been less well adopted, at least from what I've seen, because that typically adds to the overhead of your actual function. Because imagine you're running .NET on Lambda, you need to actually start up your .NET, maybe ASP.NET, you need to start up the web framework, which typically adds overhead, which people don't like because cold start is like the perennial functions problem. I actually think that's less of an issue when you're dealing with a conversational interface, because actually, I think if it takes longer to think about things, at least in my experience, I feel like it's actually...
Yeah. And the fact that it's a new interface for us in general, although it's still just like chat, but we're used to a little bit of latency. When I think it's abstracted away enough in this interface that we wouldn't know that there's like a long cold start happening in the background. It's like, oh, take your time.
Yeah. Yeah. Actually, let's just by way of finishing this off. So the Claude eventually responded with the list of products that are available. Let's just try and can you now we'll try that same. We'll try that same question we tried at the start, but obviously now I'm assuming because it's got the context of the available products, I'm assuming it will now be smart enough to say, oh, okay, I know that you want an espresso. Yeah. So it's going to go and do it now. Cool.
There we go.
So if we go actually back to our interface over here and we look at live 1728, is that right? Here we are. We've got live.
Yeah.
Live traces going through. Nice. Created your order. We've got an order ID. So yeah, that's pretty much all I had to show. I guess the main takeaway being, if you're building at remote MCP servers, serverless technologies are a fantastic way of doing that. Just make sure you authenticate it properly.
Totally. Okay. Awesome, James. This is definitely it's given me some ideas. I'm going to have to go play around with some AWS stuff now. But yeah, thanks for showing all of this off to us. I know there's probably some more things that you've got, but we could talk about that in another call. But
I'd love to.
Thanks so much. And we'll chat to you on another time.
Thanks, Jason.